All right, my name is Jensen Uyeda. I'm an extension agent with the University of Hawaii, and my area of focus is edible crop production. So I deal with um, everything from vegetables,
Join the meeting.
herbs, spices, and a few other crops that we consume. And I provide education and guidance to commercial producers, mainly on Oahu, but across the state on management practices. And today I'm going to be talking to you about some overview of taro production, at least dryland taro production. Thank you.
Hi everyone, I'm Kacie Ho. I'm an assistant professor at UH. I'm in the Department of Human Nutrition, Food and Animal Sciences, and my specialty area is actually in food science. But my lab kind of focuses on identifying and quantifying different pigments and antioxidant compounds from different types of tropical agriculture products, so including taro.
Okay, thank you guys. And I'm Monica Esquivel. I'm also an assistant professor in the same department as Kacie, but I'm focused more on the human nutrition side. I'm also the dietetics program director. I'm a registered dietitian. So I guess on the spectrum of food from field to taro, I'm the field to plate. I'm really focused on the food on your plate and getting those nutrients into the bodies of people so we can benefit from all the hard work that Jensen and Kacie do to get our food supply healthy and nourishing us. So again, I see, thank you, Pa'a. Pa'a shared she's with Kupu, the environmental education program, and she's here because she knows that Kalo rules, and thanks for sharing. If anybody else would like to share in the chat your name, the organization you're with, and why you're here with us this evening, would be really appreciated. And actually, sorry, Jensen, we did have a little Zoom poll that I was going to try to do. Polls. Oh, so we've got Stacy. And I've just thrown a poll up. So we have Stacy, they're home growers. They want to learn more about harvesting and storing. So while you're kind of sharing a little bit about yourself, go ahead in the poll. We just, which of the following best describes you? Producers, INA educators, value added, or other. And Anne, thanks for coming for your personal development. Arnold, you grow kalo as a hobby. I think that's a great hobby. We have Saw, he's a farmer in Kunia. Thank you. And I know I have some of my friends from PALS, I think I saw logged in. Tara, thanks for joining us. Thank you, everybody. So the good and bad thing about the Zoom poll, good for me, is it tells me exactly how many people have voted. So there's a few of you that we're just waiting on. Give you a couple more seconds. We got Tammy from PALS, Marvin from Hawaiian Earth Products. Thank you all for coming in. Jermaine with PALS. Yeah, I saw a whole crew of you from PALS. And Kim, home grower. Thanks for joining us, Kim. And you guys are all typing so fast. Kim, interested in dryland methods for taro. So Jensen, that's for you. Lori, personal garden. Great, thanks. And Kevin, in education. And Asia, thanks for listening in. All right, I think we got 70% of you. So, and I think this kind of matches up with what we're seeing here. And so I can share our results. We got some folks are producers, both conventional or organic. We got a handful of INA educators, value-added manufacturer, and I think that a lot of this other represents all of home growers. And
Am I muted?
There we go. So I think first up we have Jensen. And he will share. Jensen, do you want me to just keep advancing your slides for you? Oh, there you go. Now you can do it yourself. Great.
All right, so today I'm gonna cover prepping the huli, field preparation, irrigation setup, a little bit on planting, fertilization, some of the water requirement research I've done, and then a little bit in harvesting, and I'll hand it over to Kacie to talk about some of the nutritional sections. So the first part that I think is important is selecting the right huli for what you're trying to produce. So many different varieties have many different uses. So whether it's table taro, you're trying to make kulolo, you're trying to make poi, you want different colors, different flavors. There's hundreds of different varieties out there that have different culinary uses, I guess. So selecting the right plant material for its end use is really important. And then selecting healthy plant material is very important as well. So here you can see a whole bunch of different, on the right, you can see a whole bunch of different colors, shapes, sizes. Some are very beautiful, ornamental, that also have eating qualities. So hopefully I'll have enough for everybody tomorrow that comes to pick up, and some of the stuff that you may not already have in your collections. So prepping the huli, what I typically like to do is removal of all the leaves. And then I like to clean off the lower basal part of the huli, which is the top of the corm. And the reason for that is we like to cut and remove any of the previously existing soil, especially if you're giving it away to people. You want to make sure you're not passing on potential pathogens that may not be in the other person's location. And by removing a lot of the soil debris from that corm material, allows you to minimize the transfer of some of those soil-borne pathogens. So I typically like to shave off a lot of that corm material. And then once you've cleaned off your corm material or your huli, I tend to treat it with a post-harvest sanitizer. And there's a bunch of different products you can use for post-harvest sanitization. There's aqueous ozone. There's the product in the photo, which is Sanidate, which is a peroxyacetic acid product, and it's an OMRI approved product, so you can use it for organic production for post-harvest treatment. And the more common product is probably chlorine or bleach to treat the whole plant material. And what this does is basically cleans off any pathogens and potential diseases on the surface that you can then transfer to the next field. It also helps with minimizing the rot on that exposed corm that you just made down at that basal area. And after treatment, we typically let it dry overnight to basically heal itself, so that when you plant it out in the field, it's not like exposed flesh. And that way it minimizes the rot out in the field, so that during the production, you don't lose it early on. Once you have the field site that you want to plant it out, this is where you want to do your field prep based on your production practices that you choose to do so. And typically what we do is prior to planting, we'll go in with tilling and ripping and disking to kind of soften the soil to help with the production. And then we tend to incorporate our fertilization at this point. So on the right, you can see that's an application of compost, thanks to Hawaiian Earth Compost. We put down 20 tons per acre in this field, and that's a typical recommendation per acre of 20 tons per year for compost application. And this just helps with increasing organic material in the soil, with nutrient holding capacity, water holding capacity, and overall health of the soil. And we typically do that all prior to planting. Some of the other components that you might want to consider as far as inputs go, other than the compost, if you're on soil that have very low pH, you want to make sure you're adjusting the pH to at least 6 to 6.5 using a liming agent. This is a calcium carbonate product that we're liming the rows. So we don't have to lime the whole field, just the rows that we're planting in. That saves on cost so that we're not having to put in areas where we're not typically planting at that particular time. In Hawaii, soils typically have low phosphorus, so you want to potentially do a soil test prior to planting, and based on that soil test, you put in fertilizer based on those needs. And phosphorus is a typically low nutrient, so you would want to put that in prior to planting because it's relatively hard to put phosphorus into the soil, as well as calcium. So this calcium carbonate product typically goes in so that you can get the calcium in the soil. And then for irrigation setup, we typically use, for our commercial producers, we use drip irrigation. And this is a simple drip irrigation setup. You have your main irrigation line here, a valve that can shut the line on and off. Then you have a timer connected to an automatic valve, followed by a fertilizer injector. And that fertilizer injector is then hooked up to a concentrate tank, or your fertilizer solution tank, that then goes into the line and out to the field. And typically that's how we fertilize our taro fields. And then this is a roll of drip tape and our homemade drip tape roller device that we use to lay out the drip. And this is what you would kind of see out in the field on with your drip tape. And then plant spacing is a pretty important thing depending on variety. Our common spacing is about 2 feet, but some of the smaller varieties you can get as close to 18 inches. And some of the larger ones you might want to put out to a larger spacing. And that helps with, one, the foliage development or the leaf growth development, and then being able to walk within the rows so that it's not overcrowded, so you're not breaking leaves off as you walk through the rows. And then what I like to do when we're in the field is our drip tape is measured at every 4 inches. So we can just count how many drip emitters, so that we're placing a Huli at every, at a drip emitter at the 2 feet spacing. And that helps when you're measuring, or you can grab a stick that's 2 feet long. That's probably an easier way to do it than to count the number of drip emitters. You just keep using the stick to measure it out. And then once you've identified your spacing, typically I lay out the Huli first and then come back in and stick them in the ground. And I use this old school pineapple planter. So this is basically a spade, a flat spade with a curved handle. And we use that we insert it to the ground and you move it forward and backwards, and it allows the soil to move around. And as you pull it out, you can stick the Huli into the ground as you pull it out, and it allows it to go down to about 6-inch depth, which is a relatively common depth for planting Huli. Some people like to plant it a lot deeper or a lot shallower, depending on their preference. And the deeper you go, the harder it typically is to harvest, because everything is a little bit further down. And if it's a little high up, sometimes it tends to dislodge and fall over, and then you're gonna have to harvest it earlier. So you're going to have to decide how far you want to plant it, but I typically plant it about 6 inches deep from the base of the Huli. And then once you have it in the ground, looking at the fertility program, I mentioned that we pre-plant a lot of the compost, lime, phosphorus, calcium, magnesium, and other micronutrients. That all goes in prior to the planting, and that way it's there for the plant to take up. The nitrogen, on the other hand, is typically more volatile compound, where it can leach out of the soil in heavy rainfall. It can volatilize into the atmosphere under certain conditions. So we tend to just put it out as much as the plant needs during the first 3 to 4 months of production, the first half anyway of most varieties. And I tend to split that application into at least 4 applications. So it's about 100 pounds of nitrogen per acre per month after planting. And then at that point, once you've reached that point, then you start cutting off the nitrogen, and then you kick on the potassium. And the potassium is going to help with corm development, especially the size of corm and quality. And that typically gets split up as well into about 100 pounds 3 to 4 times during the last half of the production. And all of these fertilizers can be potentially injected. So one way to do the nitrogen application is to divide by the weeks in the month, that 400 pounds, and then you apply it weekly. You can apply it daily, or however often you apply your irrigation. And that allows for this micro dosing of fertilizer. So you're basically spoon feeding the plant instead of having a lot of nutrient loss to either leaching or volatilization. And typically, if you do it that way, you can maximize your fertilizer use efficiency and potentially reduce the amount of fertilizer you have to put down, because a lot more is going to be utilized by the plant versus lost to one way or the other. A fertigation system typically looks like a little bit hard to see, but we have a Venturi irrigation fertilizer injector, which basically is an inline injector that sucks water from your nutrient tank. And typically you have to use a water-soluble fertilizer. Most of them are synthetic, but there are some water-soluble or water-dispersible organic fertilizers like fish emulsion that you can use to apply nitrogen fertilizer to the field, as well as some of the potassium fertilizers are OMRI approved as well. And then a dosatron or a demo injector can be used to microdose. So every time the irrigation goes on, it microdoses in a small amount of nitrogen fertilizer or potassium fertilizer throughout the growth cycle, so that you're not having to mix fertilizer every day or every week. You can mix a concentrate tank and it slow doses over the course of that production cycle. And the objective of this program or this project was to try and increase the human nutritional components of the kalo. One, we're focusing on calcium to try and see if calcium fertilizer application could increase the calcium content within the corm and the tissue, the leaf tissue, to see if we could increase the health components of the taro. And so we decided to go and use calcium nitrate as our fertilizer source. So instead of urea, we cut back on the urea and we applied calcium nitrate to make sure that they were getting equivalent amounts of nitrogen. And then so that treatments were getting 0, 30, 90, and I guess I made a mistake. That should be 120 pounds of calcium per acre at these application dates. And then we're going to start applying the potassium this month. So the trial's a little behind our expected time frame due to a lot of factors, including COVID. But we should have some of that data available to share with everybody that has registered for this particular workshop. But we were able to get some tissue analysis done on the field. And I know our main focus was calcium, and based on the tissue results, it seems like our treatments had zero effect on the uptake and accumulation of calcium within the plant tissue, or the leaf tissue at least. So at the bottom, you can see a sufficiency range for expected tissue within the plant, or nitrogen within the tissue. And you can see that all of our values, including the one that didn't get excessive calcium, was above the recommendation. So I've should have done before, but I put in for a soil sample and the data didn't come back in time for this workshop to see if the soil calcium was sufficient. But typically our soils are, where the trial was done, is low in calcium. So I expected it to be low. I'm hoping that our future results, when we do our corm analysis, come back differently. My understanding is that the corm can accumulate a little bit more calcium later on in the production cycle. So our hopes are that it does. Based on the tissue analysis, we did have a little bit deficiency in nitrogen, but the plants itself look healthy. So I don't think it's going to be a big issue on the production. And everything else seems to be sufficient within the tissue nutrients. And then some of the observations that we got from this particular project so far is that we think additional calcium to the soil may not have an accumulation effect on the tissue calcium, but we're hopeful that we may see some of that in the corm later on when we do that analysis. There is an effect with calcium and potassium uptake. So if you increase calcium uptake, you potentially can decrease potassium uptake. And we haven't seen that, at least in the tissue sampling that I showed earlier. So that's a good thing that we're not exceeding the calcium application where we see deficiencies in potassium, because like I said, that potassium is very important for the corm development. And then everything else seemed to have no impact as far as phosphorus. And we did see that a little bit of tissue deficiency in nitrogen. So there's potential we could apply a little bit more nitrogen. This particular sample was done prior to our last application of calcium nitrate and urea. So I'm hoping that based on that application, we are meeting our sufficiency range for the nitrogen. Irrigation management, speeding a little up to meet the time frame. I typically control irrigation based on soil moisture. So the bottom right, you can see a tensiometer, which measures how wet the soil typically is. And this basically relates to the amount of pressure the plant needs to suck water out of the soil. So if you can calibrate this to your particular soil type, you can determine when you need to turn water on and off. A more scientific method is to use a weather station and a evapotranspiration model to tell you how much water is lost from the soil system and the plants. And basically you reapply water lost from that particular system. And both are a very good method of applying irrigation. And I've done trials comparing the two. So on the left, you can see a ET-driven irrigation program. This was manually applied versus this soil moisture irrigation trial method anyway. And you can see that the corm size is a little bit bigger. And most of it is because irrigation frequency was increased from this one to daily or even hourly, because it's basically taking a reading of the soil moisture and then applying water to reapply to maintain a steady soil moisture, versus this one is allowed to dry down a little bit, which is common for most commercial production. So you can see if you increase frequency, you can increase yield. And typically this treatment had less water than this treatment, but you can see an increase almost double in size. So there is benefit to irrigation frequency over volume for taro production. It doesn't like huge fluctuations in irrigation application. So if you can keep, or soil moisture that is, so if you can maintain a steady soil moisture up to field capacity, you potentially can get increased yields. And then harvest, I think this is the last slide. So typically you allow the plant to die down a little bit. That's an indication that it's mature, where you're like that fertilizer image I showed, you have plant increase to a maximum size, and then you'll have a decrease in size as it's starting to mature. And that's when you typically want to go in and harvest. And you don't want to let it get too old, because it's going to start to become what they call loli, or no more starch. And you don't want that sugar to develop in the taro, because it's going to affect cooking quality, flavor. And that's why harvesting at the right time, and a lot of it is variety dependent. It can be anywhere from 9 to 12 to 15 months, depending on the variety you're growing. And here you can see the grad students helping me cut Huli off the corm so that we can plant out the Huli and then analyze the data for the corm weights. And this would then go to our washing area, where we'll clean off a lot of the soil debris before going to market or to the kitchen. And storage typically could be up to 1 week out in the open raw like this. What I typically like to do is I peel and freeze the raw taro, and then I take it out of the freezer as I need to use it. I also refrigerate it too. I've left it in the refrigerator, peeled, washed, and in a Ziploc for about 3 weeks and just used it as I needed it. So there's different levels of storage depending on what you want to do with it. And yeah, I think that's it for the production side. I'll let Kacie take over. I don't know, do you want to do questions at the end? Okay.
Okay, and Jensen or Monica, do you think you could click for me since I'm calling in from my phone?
Sure.
Thanks. And so everyone, just a quick apology. There are helicopters flying by to put out the brush fire. So if one happens to fly by when I'm talking, just let me know and I can repeat myself. But anyways, now that you've seen the harvest, you're that much closer to eating the taro. Taro or kalo is quite nutritious. We have the nutrition facts panel up on the screen for 1 cup of cooked taro. And the reason why I'm showing it for you for cooked is because, of course, we always have to cook taro before eating it. But as you can see, it's a good carbohydrate source. It's primarily carbohydrates. There's no fat in taro unless you add it. It's low in sodium. It's quite high in fiber. It's more than 25% of the daily value of what you need. And it also contains some essential minerals such as calcium, iron, and potassium. And in case you were curious, for 1 cup of potatoes that are cooked, calorically, it's pretty similar to taro. I think it's about 200 calories. And the main differences would then be the fiber. It's actually quite a lower amount of dietary fiber from a cooked cup of potatoes compared to taro. Go ahead, Monica. Aside from different nutrients, so nutrients, vitamins, and minerals, taro also has a lot of really cool compounds, including antioxidants and pigment compounds. And you've probably noticed the pigments before when you've seen different colors of taro. So there's a couple of main types of antioxidants that my lab is really interested in. One of them is polyphenols. This is like a very broad class of compounds, so there's a lot of different types. And Monica will explain to you a little bit later some of the potential health benefits of consuming these. But some of these polyphenolic compounds are not colored, and some of them are colored. And the colored ones are called anthocyanins. They kind of range in color depending on the pH. Usually a reddish or purplish color, and depending on the pH, it can range up to a blue color even. The other compounds that you might have seen before are carotenoids, and you might be familiar with these because the beta carotene is a common carotenoid that we eat a lot, and this is orange in color. Some taro species or some taro varieties are orange in color, and that color is primarily due to carotenoid content. These pigments are a little bit different from a chemistry standpoint because they're lipophilic, so that means they like oil components, and if you consume it with oil, you generally can absorb these compounds better. And again, these are generally more orange in color, but depending on the specific type of compound, you could have more yellow colors or even red colors. Go ahead. So we were curious because, you know, there are a few different types of colored taro that we see. So Jensen was very kind and pulled a few different ones for us. The first that we were curious about was Maui Lehua, which is a purple variety that has quite large corms. And this one is used commercially, typically for poi production. The second one was Manoa. This is an orange colored variety, so the corms are actually orange. And then the third type of taro we were looking at was Pi'iali'i. And this is a red variety. It's actually red in the corm, and then also the stems are red as well. And, you know, because there are these different color compounds, you know, we were curious as to if these different varieties have different amounts of polyphenols. So in case you're curious as to how we did this, I have a picture of my graduate student, Kento, up here because he's the one who did the lab analyses for us. But basically, Jensen provided us with the different types of taro. So we had different corms that were Maui Lehua, Manoa, and Pi'iali'i. After collecting that, or after field collection, Kento went ahead and prepared the different samples. So he analyzed them both raw and cooked. In this presentation, we'll show you the cooked values. So basically, he tested a few different ways of cooking just to try to maximize the amount of nutrient retention. But the one that he found most effective was steaming the taro. So he steamed all 3 types of taro. And then after that, we actually freeze dried our samples just to preserve it for our analysis. But basically, we then quantified how much polyphenols were in each of the samples or each of the taro. And in case you were curious, a very simple way that's used a lot in chemistry to analyze the polyphenol content is a measurement, or I guess, yeah, a measurement called total phenolic content. And this is like a really broad estimation, and we express it in terms of quote unquote gallic acid equivalents. So the more gallic acid equivalents, that generally means the more polyphenols you have in your sample. Again, this is a very broad type of number, so it's good to compare if you're comparing different types of foods, but unfortunately it doesn't tell us like the specific type of compound that is in it. So that's going to be our steps later on. So in case you're curious, these are the values that we got for total phenolic content, and we converted it so that you can see it in terms of 1 cup of cooked taro. So across the 3 different varieties that we looked at, the PELE, the red version, actually had like significantly more polyphenol content compared to the Maui Lehua and the Manoa. And in case you were curious, I pulled up some previous values that were collected for baked potatoes. And those tended to range from about 500 to a little over 1,000 milligrams of gallic acid per 1 cup of cooked potatoes. So this shows us that at least our taro analyses, or for the taro that Jensen provided us, there were higher amounts of polyphenols after cooking, which is pretty cool. And what's next? You know, we have a lot of questions we still want to answer, of course. So Kento, my graduate student, is actually still working on identifying the specific types of compounds. So specifically, he's trying to focus on those pigmented ones, the anthocyanins. He's also working on carotenoid identification, so the oil-liking yellow-orange pigments. He actually told me today he shared some data, and he was showing me that there's quite a lot of what he thinks is beta carotene in the monoulu. Not so much in the other 2 varieties though. And then aside from that, we also want to do some bioaccessibility tests. So what I mean by this is where we plan to actually like model digestion, so have like a simulated digestion in the lab so that we can actually kind of estimate how much of each nutrient and or polyphenol or carotenoid is actually available for absorption. And in particular, we want to do this related to the cooking preparation. So we want to see if maybe certain ways of preparing the kalo might be better from a nutritional standpoint than others.
Okay. Well, thanks, Kacie, and thanks, Jensen. And, you know, I'm really sorry. I feel like I didn't do a very good job kind of setting the stage for why I at least really wanted to do this project and drug Jensen and Kacie along with me. You know, I was at a workshop on foods and nutrients and foods in the Pacific in New Zealand last year, and they brought up this research that was really happened quite a number of years ago, a couple decades ago, and it was showing that there was all of this beta carotene that you know, that nutrient that's in carrots in high amounts in certain varieties of bananas. And so when the researchers went to publish that, the journals were saying, absolutely not. There's no way that bananas do not have any beta carotene. Look, we have our national database of nutrients of these foods, and your research is wrong. And, you know, eventually that research was published, but what it was showing was that the nutrients available in some of our local foods are really unique and they're not represented in these like national databases that say that this food is good for you because it has this nutrient. And what that means for us here locally is that when we have initiatives like in our schools where we're trying to get more locally grown, locally sourced produce into our school lunches, sometimes it's hard for us to justify how using these different foods that are grown locally that might have more nutrients, that we know have more nutrients than maybe like a potato or some other kind of starchy equivalent. So part of the motivation was to try to demonstrate some of the unique nutrients that are found in our local food supply to maybe motivate different people in decision-making power to allow these foods into our schools, or to promote or support more of these foods into our schools and into our diets. So that was kind of the background. I'm really about like getting, I think it's great we can have all this healthy food, but we need to get it into the bellies of our kids and our people. And so that was really, part of my motivation to be a part of this work. And so really thinking about some of those health benefits of those anthocyanins that Kacie was sharing. These are those compounds in our foods that have antioxidant activity. They find these, we call them free radicals. These are these kind of cells that are a little bit out of control in our body that can cause some destruction and cells to not function properly. And so those antioxidants can kind of stop, reduce that damage. Specific to cardiovascular disease, there's been some research around how these anthocyanins can help in the process of blood clotting, vasorelaxation, so thinking of your blood vessels being very tight and constricted and potentially being damaged or leading to high blood pressure. That's kind of, they have the properties to relax, vasorelax our vessels, as well as improve our blood lipid profiles, so our cholesterol, our triglycerides. So all of these things that we see in our communities where people have cardiovascular disease and high cholesterol, these anthocyanins, if you consume them enough over time from food, are associated with improved lipids. As well as anti-cancer effects. So these anthocyanins can potentially reduce the proliferation or the growth of cell cancers and tumor formation. And with diabetes, also improve the sensitivity of our insulin that our body produces to help control our blood sugar. So really great things. Most of this, comes from eating the food. So this isn't about bottling up the anthocyanins and eating those. No, it's about eating the food and getting the benefit of the food, which I'll talk about as well. Polyphenols, and I really like to emphasize that this is like long-term consumption of foods that have a lot of polyphenols. So don't think you're going to go get a polyphenol pill and fix all of these things. But we know that, people and communities and populations where they're eating foods that are rich in polyphenols, they're protected against some neurodegenerative diseases like Parkinson's and Alzheimer's. And again, reducing inflammation in our body. And so inflammation also can cause some destruction in our blood vessels and in our organs. Anti-cancer, polyphenols promote cardiovascular health and are help to prevent type 2 diabetes, or associated with lower type 2 diabetes. And kind of where I bring it all together for me, I think about the health benefits of our food, and it's so much more than always just the nutrients and the compounds and the chemicals in the food. And so I'm referencing this Pilinaha framework by Ka'iulani Odom and her team at Kukua, Kalihi Valley. And it's really about connections. And it was an indigenous framework for health. So kind of looking at health metrics from a different standpoint. Her and her team, they work at a health center And so much of, and I'm a registered dietitian too, and so many of the projects we work on, they're looking for these health outcomes like, you know, lowered diabetes and lowered weight and all these things. And but when you ask people like about what does health mean to them, you know, their health is not described or defined by any of those numbers oftentimes. A lot of you know, indigenous people and other, you know, people, you know, we have other connections and other ways to frame our health and describe our health. And so her team did some research with a lot of the participants that work in their community and in their programs, and it was really about these 4 connections that were really health promoting. It was a connection to place, you know, a connection to other people, a connection to their past and their future, and then this idea of a connection to your better self. And so I was actually in one of her classes while I was pregnant and going through the process of getting ready to have a new family. And it was, you know, the idea that I was going to have, you know, these connections are integral to our health as well. And so a lot of what we shared today, you know, Taro or Kalo from field to plate is more than just those nutrients, but it's connecting to our place by growing our food, connecting with others and sharing that food. We can connect with our past and our future by carrying on these traditional practices of our kupuna and how they grew kalo, and then how we can support our children to grow and eat kalo as well. And then also kind of a connection to your better self, and, you know, just having that awareness of what we put into our bodies and its impact. And so it kind of just rounding out the kind of trying to bring together the more holistic and another way to look at the health benefits of the food that we eat was how I wanted to kind of end today. So I am sharing a little bit of a value-added recipe is a poi banana bread. The recipe was put together by one of our nutrition PhD students. Her name is Cherise Shelton, and she is like the baker professional person, not me. And so she adapted this recipe actually from one of the, I think, a hiko, an older hiko recipe. One of the couple of the things we tried to adapt is to reduce some of the sugar, add a little bit of whole grains, and a couple of the potential audiences we were thinking of for this value-added product in specific was a breakfast option to support farm to school. So there are a lot of farm to school initiatives going on, and wouldn't breakfast also in schools when kids are in school, breakfast wasn't really isn't well participated in. So one idea was that if we could create maybe a fun local breakfast item or item that highlights a local food, maybe it would increase the children coming in for breakfast. And, you know, another audience is people who are trying to reincorporate or incorporate poi into their daily eating habits. Of course, we'd love for everyone to just to eat poi with their meals, you know, but I think part of shifting into that new habit, this is just one idea of a way that this food could be incorporated into the diet. And so we have a little cooking demo video. So I'm going to stop sharing my screen so we can watch the video. And the video was put together by Cherise, actually, is her beautiful hands that you'll be seeing. And then Kristen, she's our master video editor, and she's our farm to school coordinator. So I'm going to share a different screen now. If I can find it. There we go. Oh, maybe not. Let me see. I know better than to just try to admit. Okay. Sorry, I'm not very eloquent at shifting all these things around. Okay, so I think I can make this big. I think it didn't quite start. And I made lots of this today, so there you go. Okay. So I think, now I think it's gonna go on to some crazy grilled cheese sandwich. Okay. I think now is the time for our open Q&A. I know that I think that Jensen has been fielding some questions in the chat. But Jensen, did you want to read any of the questions and answer them, or did anyone, you can feel free to unmute yourself and ask a question.
So the first one I saw, I think, was the dilution for the bleach. So I put in the chat that a 10% bleach solution for 30 seconds is a recommendation for a homeowner or for home use. If you're a commercial grower, you have to use a labeled product for that particular application. So you can't use regular bleach for post-harvest application. So you have to use a chlorine product registered for that for commercial use, or the peroxyacetic acid products that I talked about earlier. And each label will have a concentration as well as a exposure time for the commercial products. And then the home use one, you can use the 30% bleach. I've also fooled around with using hydrogen peroxide for home use. It's a little less chemically, I guess, than the bleach, and it does have that surface sanitization component. The following question was the fertilizer for the trial, and it looks like you got the answer, but we did use urea and calcium nitrate for the particular trial. If you were going to do it organically, there's other products that could be used in replacement of those two fertilizers. And I would be happy to talk about it if anybody's interested. The next one was small scale.
Yeah, that was my question, Jensen, too.
So I'm a commercial producer, but I also have a small backyard that I do grow a lot of different stuff, including kalo in my yard. And I typically have a raised bed that I've filled with compost, and I use that. I also have 5-gallon pots filled with taro or kalo, and then I have some on the side of my house where the rain gutter drops water. So I have multiple locations and multiple systems growing it. I've also grown it in an aquaponic system, but the system itself is not very large, so you can't grow a lot. And I typically use it more for leaf production. So I was growing a variety called apuvai, which is a very awkward looking variety, but I think historically has been used for luau leaf. So I use that one for that particular application, and then I don't usually use it for the corm. So it does really well in an aquaponic cinder bed situation. As far as the pots go, I fill that with just regular potting soil, and I add a slow release fertilizer. It's a non-organic fertilizer, but you can use fertilizers like I believe Longs and City Meal and others have smaller bags of it. It's like a chicken or turkey litter based composted fertilizer that you can use to mix in, and it's a 464. So typically I put a unscientifically, I just put a small handful every month in the pot, in each pot, to kind of make sure that it's slowly releasing fertilizer to the plant. And you can use those particular fertilizers in your raised bed or in your in-ground planting areas. And it typically does really well at a rate of about a handful per plant with that particular fertilizer. I think it's a Gaviota brand. And I think there may be a few other organic fertilizers in the same nutrient concentration that you can particularly use. Slow releases typically make it easier that you don't have to apply it as frequently as, say, a urea is a very volatile fertilizer, so it'll go in and out real quickly if you're not applying it in small quantities. I hope that answers your question. As far as irrigation, I think that was another part of that question. There are smaller scale irrigation systems, so they call them like soaker hoses or things like that that you may want to invest in to kind of attach, and then you can attach those to a hose and a irrigation timer, a battery timer, and that way you don't have to irrigate manually. But I find that therapeutic in the morning, so I do hand water everything in my particular yard when I'm drinking coffee in the morning, because it's how I like to get started in the day mentally. But there's a whole bunch of home garden irrigation systems that you can install in your yard. How do you manage taro hoppers? Commercially, there's different products. Admire or imidacloprid is one good one. Movento is a good one. Insecticidal soaps, if you can get good coverage and contact them, they're an organic option to take care of them, and you can use that in home garden as well. I do recommend late evening applications of it because it does strip the wax off the leaf. And if you do it in the middle of the day, especially in the summer, you're going to have plants that die. And it's just because you're basically taking the skin off of the leaf, and it needs some time to recover. And if you do it in the middle of the day, it'll tend to burn and look unsightly. I think those are the kind of the common hopper controls. Azadirachtin or neem oils, those tend to work too, but you have to apply, just like the soap, you'll have to apply weekly, just because there's in a life cycle of the hopper, you have eggs, larvae, or instars, and you have the mature ones. So if you spray 1 week, you may only catch the adults, and then the following week, the eggs will come out. So you might want to do consecutive applications till they're gone.
The next question is about harvesting the leaves. How far do you cut back the haw?
Depends how much you want of it. I typically cut back 6 inches about from the pico, because that's I think enough stem, because I usually cut the stems off. I don't cook with the stems just because I have so much leaf available and I prefer to eat the leaf over the stem. But if you're going to use the stem part, then I would say take whatever you want. But I take 6 inches just so that it has a little bit more moisture, I guess, till I get it home. and then I cut the rest of the petiole part off. But it's kind of up to you. You can cut it at the, I think for packing for large quantities, it's easier if there's no stem because it doesn't poke the leaf below it if you're stacking it. But it's all up to you, I think, on how you want to do it.
And then the next question from Lori, is there a database that identifies different varieties, edible versus ornamental?
So CTAR has a book. It's Bulletin 84, 85. I think if you type in or Google search CTAR taro varieties, there is a bulletin that does specify historic uses of varieties. So what varieties were used for what particular dish, I guess. So if you're, like I said, if you're making kulolo or you're making table taro, there's they distinguish certain varieties for those certain uses. But as far as determining whether it's an ornamental or commonly commercially edible variety, I guess, I don't typically know all of the ornamental ones because there's a bunch of them that have been produced. So I wouldn't be able to tell you the differences. So I think getting your plant material from a reputable person that knows what they're doing or what they have, I think, can help you determine whether or not it's edible or not, and what variety you actually do have.
Oh, wow. And then Arnold had a question about irrigation. Is it constant during the growing cycle, or do you decrease watering prior to harvesting?
Yes, typically I keep it constant. When it's establishing, you may have to go more frequent just because there's no root system when you stick the plant in the huli in the ground. So typically as the roots development increases, you can increase the duration of the irrigation to wet further out. If you're using a drip irrigation system, if you're using a home garden system, it's the same concept. You don't have to apply a lot of water because there's not a lot of roots for it to take up. You just want to keep the area around it sort of moist so that it can grow, it can start initiating roots. And then yes, typically towards harvest, you're cutting back on the water and you'll start to see the decline in growth as it matures. And then prior to harvest, I typically cut water unless the soil that you're planting in is hard. Sometimes people want to increase the moisture because it allows for easier removal during harvest, because we're harvesting everything manually with pitchforks. So softer soil is a little bit easier to get the whole corm out of the ground without breaking or damaging the corm. Hope that answers it. I think there's another question further up about brand of cleaning product that is okay to use in organic growing. So commercially, the product that I use is called Sanidate, 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 and that particular product active ingredient is called peroxyacetic acid. I can type it in the chat. And it also has hydrogen peroxide mixed in with it. So it's basically a vinegar and hydrogen peroxide solution that has sanitizing capabilities. And I believe that one is like 85 parts per million is the dilution for a minute exposure time. And but you'd have to double check the label when you purchase it. The other option at home would be to use hydrogen peroxide instead of the bleach. That would be a semi-organic method of sanitizing it on a smaller scale. I've never worked with using stuff like vinegar because it's an acidic product. You're basically using the acid to kill the pathogens, but I don't know how effective vinegar is on controlling some of the surface pathogens that are going to affect the growth on the huli.